Kuryr was presented quite a lot in OpenStack Tokyo. It was presented in the keynote. Kyle Mestry. And I think the reason why so much attention in Tokyo is because Project Kuryr tries to solve very important challenge in OpenStack. Basically, it's trying to get and bridge between containers world and OpenStack. And it's doing it in the networking space, and I will show you. A little bit, few words about OpenStack. Development and design. Beside Project Kuryr, we also contribute to Project Dragonflow. It's a Neutron implementation, which has very interesting concepts. New project that was presented in Liberty called SMART, hybrid cloud solutions, and so on. And I would like to welcome all of you to come and talk with me. We are always looking for users, contributors, people to collaborate with. And this is my blog. I write about all the projects, including Kuryr. You find it. Before I start dwelling into Kuryr, Neutron. I know Neutron. So Neutron is OpenStack networking abstraction. It lets you define these elements, like virtual ports, virtual network, virtual subnets, connect them with routers. And with these elements, you can build things like very sophisticated application virtual networks, models, application networking. It's very similar to how you would model it in the physical networking world. An important point about Neutron is that people sometimes mix is that Neutron is not the API there. There is the reference agents with the namespaces. But this is just one implementation of Neutron. There are right now, I think, over 60 different drivers that implement Neutron API. Some of them are open source, some of them are proprietary. But it's important thing to note that Neutron, in its essence, is an API layer. Now, if we look at the Docker network, you are with the Docker, but basically Docker has a driver, usually. The network is still experimental, but it's next generation networking for Docker. It's done through the acquisition of Socket Plan, if you heard about it. Lib network lets you define these elements like network, endpoints, connect them, and lib network is pluggable. You find your own driver, these API calls, and implement networking even without the Docker Zero bridge in any way that the driver wants. So the big questions that led us to start Kuryr is, where have I seen it? Well, it's one slide before. When you come to think about it, Neutron and network are very similar. Like the abstract networking model, and we provide pluggable drivers to implement this networking. And talking in the summit in Tokyo, we talked with a lot of people that deploy containers networking and implement containers networking solution. And there are arguments if VM networking is different than containers networking and so on. The thing is that abstract API expression point of view are very, very similar. So before I'll describe the problems that we solve in containers networking world today, which led us to start Kuryr. So the first problem is what AI for OpenStack, and so on and so on. And these models are still very unmature. They are evolving all the time. Following over API, they change few months ago, they change completely the way they launch containers with the network, and now they are adding they added unpluggable IPAM. So these things are not very stable right now, and they are keep changing. If you look at Kubernetes, so these things are evolving, and new abstractions are being created over and over. We also saw there are many container-specific networking solution like WIF, Lamel, Socket Plan, which is now Docker. And these solutions are also new and trying to be very small demands of the networking models for containers now. You can see here all of these new solutions. Important to note that I mentioned that Neutron has around 60 drivers right now. But some of these solutions are actually trying to also provide integration with containers networking. Some of them integrate with Kubernetes, some of them integrate with operating network. And all of these are doing it in a separate place, in their separate repository and redoing things. And it's important to note that it's very hard to, because all of these instructions are evolving and changing. It's very hard to keep track, and solutions are always changing, constantly changing. A networking solution which has quality measurements and has gate and functional test and CI and is being QA is not something that is easy to build, and it shows in containers networking. Another problem that we noticed in containers networking world today is what we call the double overlay problem. A very common deployment for containers today is when you want to do tenant isolation, some security problems with Docker. Usually you deploy containers and VMs on your computers. Anyone familiar with Project Magnum? Project Magnum is basically right now all about that. We are going through metal deployment, but right now Project Magnum defines Kubernetes as both phase, a group of tenant VMs, and you could deploy there your orchestration engine of your life, like Kubernetes, Docker Swarm, and manage your containers. Now, when you look at the networking for such solutions, so you have the networking that connects between the VMs. This is usually a Neutron plugin of some sort. And then you have another different solution inside the VMs that take care of containers and networking, like Kubernetes. This model shows there's a lot of problems in terms of performance and latency throughout the constellation of these layers. But more than the performance problems, in this model, we also have here, when we come to think about management, about debugging, about health checking, upgrades, updates of this solution, orchestration, deployment. These solutions that are building our network has to relate to containers. So, yes, we can overcome the performance with all sorts of solution, but we still have all extra problems which we don't notice them right now, but we will in the future. So these are the problems that are in Project Kuryr. In Project Kuryr, this sentence sounds pretty good. We identify that we already have a networking abstraction. It's relatively mature, tested, and this is the Neutron, the networking OpenStack abstraction. And in a mixed OpenStack environments, and even not in environments, we believe that using Neutron and using that So how Kuryr tried to solve all the problems that I mentioned before. We are trying to model all these new models for network, Kubernetes, CLI, and so on, and map them to Neutron API. I'll show you soon how we do it. And by doing this mapping, we basically get vendor lock-free solution for containers, because now any Neutron plugin out of these 60 drivers that I mentioned can be used for containers networking, whether it's bare metal or whether it's nested containers. We'll see in a second. And this is a very big advantage. And you have solutions that are relatively more mature in containers world today. Excuse me? No, I'll show in a second how we do. More than that, we are already few solutions in neutron drivers. There are many neutron solutions that are tackling problems like that. What I'm trying to do is basically have one solution, one networking infrastructure, both for containers and networking. And when you have one solution, you solve a lot of problems that I mentioned earlier. The level of constellation could be saved, the management is much more easier, and I'll show you in a second how they do it. And another very big advantage of it is from the device, like snapping and so on, and of course, advanced neutron services like load balancing service, firewall service that we can now deploy and use in our containers networking environments. So this is high level the problem, the solutions that we are trying to solve here. A little bit overview about the project. Kuryr is a fully open source project. Currently, it's part of Neutron Big Stadium. Due to some changes, we are going to be under Big Tent. Doesn't really matter. We are trying to we are trying to basically bridge between two communities. The containers community, which has a lot of parts in it, like Docker and Kubernetes, and the OpenStack networking community, Neutron, Project Astara, if you heard, and all the others networking in OpenStack. We are doing everything OpenStack with, which you can join, launch the mailing list, everything is open, the designs are also open, and you're free to come in. We're also working very closely with related containers project in OpenStack, like Project Magnum. So the mission is for Kuryr to be a big Project Magnum. Basically means that Magnum uses OpenStack networking abstraction. And we also work with Project Cola, if anyone familiar with this. Project Cola is about containerizing all of OpenStack services. And we are working on containerizing all of Neutron drivers for Neutron server, for different agents or different solutions that needs to run. Something that makes deployment easier, and in some environments it's mandatory. Just quick, this is the contribution states to Project Kuryr. Might be a little outdated, but I think the important point to show here is that it's really a community effort. There are a lot of companies that are joined and are actually contributing to the project. Besides this company, there are a lot of other companies that we are in discussions about designs and use cases. And we found out that this is something that people are were thinking about are trying to do themselves, and having a joint focus point is good for us. So I'll go over now what we do in Kuryr to implement all of these solutions that I mentioned. Kuryr is still relatively early. It started like 2 months before Liberty, so in Mitaka will be basically our first release for the project. Um, Kuryr architecture, as you can see it in this diagram, and I'll dive into all of these points here. Uh, it has full integration with Docker, so we are now fully supporting Docker Neutron. Docker added the platform icon support. We are making this Neutron already has icon support, pluggable icon, so we are mapping this to Neutron. We are now working on a design for Kubernetes driver integration, and I'll describe all of these points. Big network. As I mentioned, big network has a write your own driver that actually Docker CLI or API, implement the networking as you wish. So what we do is Kuryr service basically hijacking both the Docker API, converting it, and mapping it to Neutron API and Neutron features. It's sometimes a little bit challenging, but the API is still something that we're able to do with some sort of mapping. And by doing this mapping, basically every solution that works for Neutron is now working for Docker networking using the Neutron backend infrastructure. In order to support this, we are trying to do all of the common work. We are yes, Neutron API to do the mapping, but we have identified that there are places in which we cannot do common work. Some places there are backend embedded, depending on the networking solution. One of them is the virtual interface binding layer. Several solutions for Neutron have different networking infrastructure. So have OPS bridge, Linux bridge, and something else. The process of connecting the container namespace to this infrastructure is different depending on the infrastructure on the packet that you choose. So what we do, and this is something that we do commonly with Nova, because of course they have the same issue, is to have a common big binding library. So as a backend, you need to write a very short script that does this binding between the container namespace and the infrastructure. What Kuryr does is trying to do the IPAM, the V Ethernet pair creation, and everything that is common, and then sending to the script the metadata or the V Ethernet thing that it needs to know to do the final binding between the namespace and the infrastructure. When we talk about deployment, Kuryr mission is to simplify the way that we deploy networking for containers. So it was very important to us to be very orchestrated. We are working on packaging for Kuryr, RDO, and we are working, as I mentioned, with Project Koala to offer Kuryr containerized, in addition to all the other Neutron backends. The way that Kuryr deployment looks like in OpenStack right now, this is something that is a little bit trickier. At the bare metal mode, Kuryr service is located next to the Docker agent. Kuryr service also register Docker agent, Docker API, and now here it's important that we are trying to address a lot of use cases that we heard from people. For example, very big use case going containers at scale. We are asking, and it's something that we were supporting. So this is the deployment for bare metal. For the nested containers, it's a little bit more trickier, and this is something that we are still in design process. Here, you could think about the default solution would be to deploy Kuryr service, same nested in the VM. But there are some challenges here. For example, how the VM can access Neutron API, how we solve the problems for nested containers that we also want to connect the VMs that hosting these containers. And there are some very interesting challenges here. Other challenge is how Neutron solution actually solve this problem. We saw things changing from Kubernetes to VM, from having an OPS class running in the VM to things that does layer 3 networks. Extended PPF, if you heard from Plumbizer, and there's a lot of solutions. And Kuryr mission is to find a common API to be able to expose it to the orchestrator or to the user in order to be compatible. And I'll touch this. So this is something that we're still designing our solution, how to solve the API, how to manage nested containers and VMs networking with one service. For the nested containers, there are already, as I mentioned, a few solutions that solve this problem. The main thing to think here is that we first, if we take aside for a second the performance and latency problems, having one solution, finding, connecting your network both for the nested containers and terminal is already very big improvement in the way that people are deploying these environments. There are already solutions to solve. They are not yet mature. They are evolving and they are getting a lot of traction. There is OPN. So OPN has a way to solve this issue. We also solve this in kind of a different way. Ethernet in a different way. As I mentioned, that Plumbizer are having their own solution. And Kuryr mission is to expose all of this solution to the user, to Magnum, and to anyone that wants to orchestrate and build this kind of networks. The idea usually in this solution is that we are treating the nested containers just like we would treat any other Neutron port. So the immediate thing that we gain is that we can have an isolation from the network that the VM itself is connected to the tenant networks that the containers are connected to, and of course mix and match networks between VMs and containers. Now, in most of these models, the trigger part is the security aspect. Where you deploy your security. Each solution solves it a little bit different. If you look at the OVN case, usually they have an OVS bridge, VM, the container, and then all the logic is done in the hypervisor itself. But again, there are many other ideas. We have our own idea in Dragonflow for implementing this. Still too early to speak about all of this, but I believe that in the next cycle or the cycle after it, we're going to see very, very nice solutions in it. Yeah. Security groups is difficult if you want to apply security groups between the nested containers. So the question is, if you want your traffic, you could have few alternatives. You could have your traffic, even if two containers that are speaking inside your VM as some sort of security group restriction. You could have your traffic traverse to the hypervisor and then back up. But this is the idea here. The deployment is still as an end. You mostly want to do security groups.
Purple arrow? Yeah, because here now you have it run, right?
Yeah.
Yeah.
Yeah, exactly. So you support the security groups in the hypervisor. Okay. Tagging is done here, and support it in the hypervisor itself. But again, it's still, for example, there is a solution from my iOvisor. I don't know if you're familiar with a company called PlanGrid. They're doing something extended BPF. It's a technology where you could inject to the kernel some program you write in C. It's supposed to run in a safe mode, and they're applying security enhancements there. And they're doing tree networking. There are many solutions in this area. But actually, the trend that I'm looking at is basically the opposite. This model is still something that Magnum provides, and I think you can also see. But the trend that I'm actually seeing, and this is what we are running bare metal. The assumption is that we're going to see enhancements in Linux and enhancements for security. So in the near future, or in the future, I don't want to say profits, but we are going to have some sort of multi-tenancy security even on bare metal between containers. So we are in Kuryr, we are bridging between containers and Neutron. We are also identifying some features that are missing in Neutron and that we implement in order to support feasibility or other things that are needed. We're pushing these features in for example, some of this coding is something that is thanks to resources. The VLAN trunk and the DNS are something that are also all of these use cases are actually areas of career, both coding, feature for providers that public IPs. So it's something that people want regardless of the career. Support forwarding, feature parity with port mapping, with open port mapping, adding tags to resource. It's a simple use case. It's a simple feature. But there are many use cases for it. One of them for career is to allocate those elements of the defining them in some way to them and filter according to them. There were some other instances like where you deploy your VMs for networks. If you're familiar with, there is a problem layer 3 routed networks in Neutron, where you don't know where your hypervisor is going to be deployed in terms of your public IPs network. So this has a lot of use cases. The VLAN trunk API is actually a feature that we are not pushing, but it's something that is being done for the NFV use cases, and we are leveraging this to define the nested containers API. So the API will be generic. There will be parent port, subports, where you can define these ports in Neutron. VLAN trunk, adding tags to resources for Mitaka. DNS resolution is already merged from what's for Liberty. The VLAN trunk API is something that's a little bit delayed. There are ways to overcome this. Just for API, needed. And the port folding I need for the next slide. DNS resolution for port is something that's been merged in Liberty, being able to DNS your Neutron ports by name. It's a work that merged between designated DNS as a service and Neutron. By doing this bridging, as I mentioned, we are getting a lot of networking. Already, for example, there are already ideas how we could enhance Kubernetes. For example, API Kubernetes supports something that's called annotations. You could send tags, labels, whatever you want to call it, to your driver that implements your networking. And we are able to enhance this API by adding options to configure security groups for Kubernetes and so on. And we could map all of these additional features to Neutron API because we are using it. And of course, we are also thinking going ahead about using advanced services for Neutron, like Kubernetes as a default service, able to use Neutron service and so on. And the thing is, we get all of these features effort-free, and as Neutron progress, of course, these features are being gate tested and functional testing, and I think this is the point that sometimes people very point want to ask it's perfect. Yeah, I won't say it's perfect, but it's a lot more.
So you can run it as a container.
Any advanced solution that is supported. For our roadmap for Liberty, all the Docker is already integrated. So elements. That's interesting. We have the generic binding supporting the few solutions, all the configuration and authentication features. And we are pushing the Neutron specs that I mentioned earlier. Mitaka, we gave ourselves kind of a challenging roadmap. We actually changed priorities from users. We tested containers on the side, and now we are working on integrating pretty much a lot of demand. But we are going to support the containers after it, containerizing all the plugins, adding the icon, as I mentioned. And going further, we are also looking for the next release, as I mentioned, do full integration with advanced services like the load balancing, version 2, firewall as a service, Project Astara, anyone heard? Kanda? Start of Kanda. Okay, so Astara is the interesting project itself. It's orchestrating routers or gateways, yes. idea is that this is a framework which orchestrates and scale out, scale down your demand depending on your load. So it's an interesting project, and we're thinking about how we can leverage that as well, and support for Mesos as well. I would like you all to join us. Really believe that this project has big goals, it has a lot of benefits to anyone that is interested in this environment. They are very welcoming. As I mentioned, we have a weekly IRC meeting. We're talking on the Neutron channel at Freenode. There are a lot of documentation and blog posts that can be read and, about Kuryr. And anyone that wants to talk with me after it or a few days, feel free to reach. We're always looking for new people. Thank you. Thank you.